parallel and perpendicular lines. First of all, we're going to review. Number 1 says find the reciprocal of each fraction. The reciprocal is when the numerator and the denominator of the fraction flip places. So for example, on number 1, it says 1/2, so the reciprocal would be 2 over 1. What would the reciprocal for part B be? 4 over 3. Part C? Part D? The answers should be 3 over 4 for part B, negative 3 over 1 for part C, and negative 2 over 5 for part D. Number 2, find the slope and the y-intercept of each equation. So quickly up in the top, I'm going to review y equals mx plus b is which form? Hopefully you said slope-intercept form. And the m represents the slope, and the b represents the y-intercept. And we always write y-intercept as an ordered pair, and so it's 0, comma, whatever the number is. So on part A, the slope, m, would be 5 over 4, up 5, right 4, up 5, right 4. And the y-intercept, b, would be 0, comma 4. Okay, on part B, what is the slope? What is the y-intercept? Okay, the slope is 5 over 3, and the y-intercept is 0, negative 8. Part C looks a little bit trickier. It's missing some information, and we have to decide what is it missing. Well, we have this part that says 6x, and the 6x is like the mx. And so this would be our slope. M equals 6. And we like to think of our slope as a fraction because it tells us the rise over the run, or the change in y over the change in x. So if it's not a fraction, we just put a 1 underneath. The b, well, looking right here, I don't see anything for b. So that just means that it's at 0, comma 0. And so on your graph, whenever you graph this line, it's just going to cross right at the y-axis, or right at the origin like that. Okay, part D, the slope is 6 over 1. The y-intercept is 0, comma 2. Number 1 says, what is slope-intercept form? We just talked about this. Hopefully you remember. Slope-intercept form is y equals mx plus b. M stands for slope, B stands for y-intercept. Number 2 says, what is standard form? We just got done using elimination about a week ago, and we remember that standard form is when x and y are on the same side of equals, and we write it like this. ax plus by equals c, and a, b, and c are just regular numbers, and x and y are the variables. Number 3 is a new form that we've never learned before. So this is one that you're going to need to start being prepared to learn. It is called point slope form, and it looks like this. Y minus y1 equals m parentheses x minus x1. This formula is going to help us to write equations the rest of this week. What you need to know today is that m is still representing the slope. The y's and the x's are just representing x's and y's of ordered pairs. We'll talk more about this form to come, but just know all 3 of these equations are linear. If we graph this, this, or this, they would create lines. Number 4, find the negative reciprocal of each fraction. So negative means that if it's positive, you change it to a negative. If it's negative, you change it to the positive. So negative is just pretty much representing the word opposite. So I'm going to write that over here so we remember. Negative is just referring to the opposite. So on part A, it says 2/5. The negative or opposite reciprocal would be negative 5 over 2. First of all, if it's positive, it changes to negative, and then the reciprocal is when the numerator and the denominator flip spots. So part B, what would the negative or opposite reciprocal be? Hopefully you said negative 7 over 3. Part C already is a negative. So when I find the opposite reciprocal, it would be negative 2 over 1. And we see that there's a 1 on the bottom. So a lot of times we'll reduce that to just be negative 2. Because negative 2 over 1 is the same as just negative 2. And what would you think that the opposite or negative reciprocal of part D would be? Yes, 3 over 4. Positive, because we do the opposite. So parallel lines, they are lines that, never intersect. It says, what is the slope of the red line? So I'm looking at the red line, and I'm going to have to find two perfect points. I see one right here, and I see one right here. Slope is change in y over change in x, and this is going up 1 over 2. So the red line has a slope of up 1 over 2. Now what is the slope of the blue line? I'm finding two perfect points, up 1 over 2. So if you notice, both of these slopes are exactly the same, and these lines are parallel. So parallel lines have the same slope. Parallel lines, it says determine if these lines are parallel. Okay, your first note is in order to tell the slope, you must be in slope-intercept form. So I'm just going to write this down. Must be in y equals mx plus b to determine slope. So if I look at the very first equation right here, this equation is in standard form. So I'm first going to have to alter that equation to be in y equals mx plus b. So I am going to subtract 2x. The 2x minus 2x is a zero pair. So now we have 6y equals negative 2x plus 12. Then I'm going to divide everything by 6. And so y equals, this fraction is going to reduce. Negative 2 over 6 reduces to negative 1 over 3. And then plus, we have 12 divided by 6, which is 2. So we are looking at this equation and this equation, and we're wanting to know if they are parallel. Well, again, parallel means that they have the same slope. So if we look at this slope, negative 1/3, and if we look at this slope, negative 1/3, they do have the same slope. So I'm going to write that down. They have the same slope. And so that means, yes, they would be parallel. Okay? The y-intercept doesn't matter. So the plus 2 and the plus 5, that doesn't matter. All we're looking at is the slope in order to determine if they are parallel. Okay, another one. Determine if the lines are parallel. Our first equation is in standard form. So what we're going to have to do is change it to slope form. So I am subtracting my 6x to the other side to get a zero pair there. Now we have 8y equals negative 6x subtract 24. Divide by 8 to all terms. And so y equals negative 6 over 8 can reduce to negative 3 over 4x minus 24 divided by 8 is 3. So here's this equation, and we are comparing it to this equation. Now, this slope is 3/4, and this one is negative 3/4. Well, the positive one's going to go up, and the negative one's going to go down. So there's no possible way that these could be parallel because their slopes are different. Slopes are different? No. 4x plus 6y equals negative 2. Y equals 2/3 x minus 8. I want you to try this one. Take the standard form equation of the first one, convert it to slope-intercept y equals mx plus b, and see if they are parallel. Okay, let's check. Subtract the 4x. So now we have 6y equals negative 4x subtract 2. divide everything by 6. And so y equals negative 4 over 6 is going to reduce to negative 2 over 3x minus 2 over 6 reduces to 1/3. We are comparing it to this. Well, this slope is 2/3. This slope is negative 2/3. That means the slopes are different. And so hopefully you said no, the lines are not parallel. Okay, let's move on to perpendicular lines. Perpendicular lines are lines that intersect to form blank angles. Look over here at the picture for just a minute. Right angles, if you visualize this, there's a right angle. How many degrees is a right angle? 90 degrees. So perpendicular lines have to make a 90-degree angle where they intersect. If they don't, here's an example up top. These two lines are intersecting, but this right here, this angle, is not 90 degrees. So those would just be intersecting lines. They are not perpendicular. Okay, first question says, what is the slope of the red line? So on the red line, I've got to pick two perfect points. I see one here and one here. Now this slope is going downhill, so I know my slope is going to be a negative. And it looks like it's going down 1 over 1, 2, 3, 4. So down 1 over 4 is the slope for the red one. Now I'm looking at the blue line and I'm finding two perfect points. I've got one here and here. It's going uphill, so it's positive. It's going up 1, 2, 3, 4 over 1. So this slope is positive. Whoops, and I wrote that backwards. It's going up 4 over 1. So as you notice, if you look at these two slopes, they're called opposite reciprocals of each other. One of them's negative, the other is positive. And the reciprocal means the numerator and the denominator flipped. So perpendicular lines will always have opposite reciprocal slopes. Opposite reciprocal slopes. So if I told you had a slope of 5, then the parallel slope would be 5. But what if I asked you the perpendicular? The perpendicular would have to be negative, and the reciprocal of 5 would be 1 over 5. Perpendicular lines. What is the slope of the perpendicular line? So part 7, if we're given this equation and we want to know what would it be perpendicular to, we're first going to look at the slope. This slope is 2/5. And so the reciprocal would have to be 5 over 2. And because this one's positive, we would have to be negative. So what is the slope of the perpendicular line? Negative 5 over 2. Okay, number 8. Slope of the perpendicular line. We do the reciprocal, so 5 over 1. This one was negative, so this one has to be positive. And 5 divided by 1 is just 5. Okay, last one, the slope is negative 2. And here's what negative 2 looks like. This is negative 2. So our opposite reciprocal is going to be positive, and it's going to be the reciprocal, so it's going to flip. So positive 1 over 2 would be the perpendicular slope. Determine if the lines are perpendicular. We're checking their slopes to see if they are opposite reciprocals. Again, you must be in slope-intercept form, so y equals mx plus b. So our first equation is, and the first equation has a slope of 2/3. So if the other line is going to be perpendicular, what slope would it have to have? Hopefully you said negative 3 over 2. Well, let's check. I'm going to put this one into y equals mx plus b form. Divide everything by 3. And so we are left with y equals negative 2/3 x plus 4 over 3. And I'm looking at the slope. Are these two slopes opposite reciprocals? No. They're opposite positive and negative, But if this is 2 over 3, then this slope would have to be negative 3 over 2. So these lines are not perpendicular. Okay. Determine if these are. Our slope is 4 over 3. So now we check the second equation. I'm converting it into slope-intercept form, y equals mx plus b. Divide everything by 4. And y equals negative 3 over 4x plus 9 over 4. And I'm looking at my slopes. So this is 4 over 3 positive. So my other one will have to be negative and then flipped, which negative 3 over 4 this one is. So that means that these two lines are perpendicular. I almost wrote no. Yes, these are perpendicular. That means that when they cross, they make a 90-degree angle. That's the definition of perpendicular. The one last thing that I wanted to show you, think about this slope. If I had a graph, here's my x-axis and my y-axis, x and y. And let's say that I had this line right here. Actually, what if we looked at the x-axis for a minute? What's the slope of the x-axis? The x-axis has 0 slope because it's straight horizontal. Okay, now let's look at the y-axis. It's vertical. The y-axis has undefined slope. So you're going to be asked questions like this. Given the line y equals 2. So here's 1, here's 2 on the y-axis. So there's the line y equals 2. They'll say, what is a slope? Well, the slope would be 0 because it's flat. Okay, well, what about this equation? What if we said x equals negative 3? On the x-axis, 1, 2, negative 3. Here's that line. That slope, m, would be undefined because it is straight up and down. So remember, undefined is straight up and down. And if you look, the y-axis and x equals negative 3 are parallel. And I said that backwards. The y-axis and x equals negative 3 are parallel. The x-axis and y equals 2 are parallel. But what do we notice about y equals 2 and x equals negative 3? You should notice that they're perpendicular because they're creating a 90-degree angle.